Hello, welcome to Syllabus Simplified. This is the second lecture of the series of lecture we are going to do on electrostatics for your IIT JEE and medical entrance examination and also other engineering entrance examinations. Today we are going to study about the different methods by which we can charge a body, the methods of charging. The first method is by friction. As we studied the last day that a body acquires charge whenever it has excess or deficiency of electrons, because electrons are loosely bound to the atoms. They can easily be taken away from atoms or given to an excess in the solid lattice of the material. So whenever there is excess of electrons, the body possesses negative charge, and whenever there is deficiency of electrons, the body possesses positive charge. This was discussed in our previous lecture. Now, what happens if we try to charge a body by friction? Friction means we are rubbing two bodies with each other. The most common example is if we take a rod made of glass and we rub it with silk. So here there is friction between the glass rod and silk. What will happen if we do that? The electrons from the glass rod will move into the silk cloth, for which the glass rod will have deficiency of electrons, because the electrons from the glass rod has moved to the silk cloth, and the glass rod will become positive in charge, whereas the silk cloth will become negative in charge. On the other hand, there is one more example where we rub a rod made of ebonite with wool. In this case, electrons from wool will move into the ebonite rod, for which the ebonite rod will have excess of electrons and it will become negatively charged, whereas the wool will become positively charged. This is how we charge a body by friction. So when there is friction between two bodies, electrons are made to move from one body to the other. The body which loses electrons become positively charged, and the body which gains electrons becomes negatively charged. The second example or the second method is by charging by conduction. As shown in this diagram over here, this is the method which is showing how a body can be charged by conduction. Now over here we have a charged body. This is a charged body. This, as you can see, is a charged body, and this over here is an uncharged body. And when we touch the charged body to the uncharged body, as you can see, this body is positively charged, which means it has deficiency of electrons. Now if we touch it to the uncharged body, it will try to take electrons from the uncharged body, free electrons from the uncharged body, for which the uncharged body will lose electrons which will go into the positively charged body, and when we separate them, both will have positive charges, but now the positive charge of both the bodies will be half of the positive charge which the charged body had initially. So if it had a charge q, after separation this will have q divided by 2, and this will also have a charge q divided by 2. What would have happened if the charged body had a negative charge? If it had a negative charge, then which means that this would have had an excess of electrons. So when we touch both the charged bodies and the uncharged body, the excess of electrons from this would have moved to the other body, and both of them after separation would have q by 2 and q by 2 charge. This is how we charge body by conduction. It means the electrons get conducted or moved from one body to the other body. Here also, as you can see, electrons moved from the uncharged body to the positively charged body, making the uncharged body half the charge it had, the charged body had initially, and the charged body itself became less positively charged, that is, it became q by 2. The third method is by electrostatic induction. What happens over is that we initially have an uncharged body. So the body over here in this stand is the uncharged body. Now we bring a charged rod in front of it. Suppose over here we have brought a positively charged rod. Now what will happen? Due to Coulombic attraction, which we know that opposite charges attract each other, this positively charged rod will attract the free electrons in this body towards it, whereas the positively charges will be repelled in the other direction of the rod. So what will this positively charged rod do? It will attract the free electron towards it, whereas the opposite side will become positively charged. So this is the opposite side which is positively charged, and the free electrons get attracted towards the rod. Now if the opposite side, that is this side, if the opposite side is earthed, that is connected to earth, then it will gain electrons from the earth and the opposite side will become neutral, and the opposite side will become neutral, whereas there will be free electrons which were attracted by the rod. Now this will be the scenario if we move the earthing, that is, the free electrons will remain attracted by the rod, whereas we have removed the earthing. So there is no earthing over here. There is no earthing over here, as you can see. Now if we move this rod away from the charged body, then what will happen? These free electrons which were being attracted by the rod, when the rod is removed, will get evenly distributed in the wall. Why will they get evenly distributed? Because we know like charges repel each other, so they will try to be as far away from each other as possible. So after that, this body as a whole will possess a negative charge, As you can see, we have not touched this rod to this ball. We have just kept this rod nearby to this ball. The inducting body, that is this rod, neither gains or loses any charge. Which body gains or loses its charge? The body which is being induced. The induced charge in this body can be lesser or equal to the charge of the rod or the inducing body, but it can never be greater than the charge in the inducing body, or it can never be, the charge in this body can never be greater than the charge in the rod. The induced charge is given by this equation, which is, that is, the charge induced in the body q prime is equals to minus of q 1 minus 1 by k, where k is the dielectric constant of the material. In our further lectures, we will come to know what is dielectric constant. This equation will help you in your entrance examinations. And as you can see here, over here there is a negative charge, negative sign. What does this negative sign tell? It tells that the induced charge in the body is always opposite to the charge of the inducing body, or that is, the charge gained by this body, the charge gained by this body is opposite in sign to the inducing rod or the inducing body. It's always true. So as you can see, the equation over here, as you can see the equation, it is q prime, that is the charge gained by the body, q prime, that is the charge gained by the body, this is q prime, q prime is equals to q, that is the charge of the inducing body, this is q, minus of q 1 minus 1 by k, where k is the dielectric constant of the material. And regarding dielectric constant, we will study in our further classes. Basically, dielectric constant somehow tells how much a medium allows electric field to pass through it. Thank you very much for watching the video. Please like and subscribe. Thank you for liking and subscribing to my channel.